So hello and welcome students to another new video of Newton Gate, where we make your dreams come true. So today I have come up with an interesting chapter of class 6th grade, that is the magnetic properties. So we'll learn today fun with magnets, okay? So today we'll learn about a very interesting chapter of class 6 standard, that is magnets and magnetism. You may find the chapter named as fun on magnets or something else other in your books, but the basic thing is on the magnet and the magnetic properties, okay? So let's get started without wasting any time. So the topics we will be discussing will be: what is a magnet? Magnet and non-magnetic substances, different types of magnets, laws of magnetism, properties of magnets, Earth's magnetic field and magnetic field lines, magnetic effect of electricity, electromagnets and its uses at the end. Now let's first learn about the discovery of the magnet. How was magnet discovered? There is a story which tells that a shepherd named Magnus, he was herding his sheep in an area of northern Greece called Magnesia about 4000 years ago. Suddenly both the nails in his shoes and the metal tip of his staff became firmly stuck to the large black rock on which he was standing. To find the source of attraction, he dug up the earth to find lodestone. So lodestones contain magnetite. This was found later, natural magnetic material. This type of rock was subsequently named as magnetite, after either Magnesia or Magnus himself. Now the first question which arises in our mind is that, what is a magnet? A magnet is a substance that attracts iron and other magnetic objects towards it. We know it very well that they are the naturally occurring or artificially made substances with the property of attracting iron. Not only iron, but all the magnetic substances we'll discuss about later. The property of substances due to which it can attract elements like iron, nickel and cobalt is called magnetism. Now comes magnetic and non-magnetic materials. Substances that are attracted by a magnet are called magnetic substances. Example: iron, cobalt, nickel, etc. Substances that are not attracted by a magnet are called non-magnetic substances or materials. For example, we can find a lot of examples in or around us. For example, aluminium, copper, wood, glass, etc. In the diagram below, you can see it very clearly. Now comes the next topic, natural and artificial magnets. It is found that some naturally occurring rocks have the property of attracting small pieces of iron. Hence they are called natural magnets. Natural magnets are the magnets that can be found in nature. For example, lodestone. It is also known as magnetite. Whereas artificial magnets are magnets that are made by man. For example, an electromagnet. So let's discuss what is an artificial magnet. An artificial magnet is a magnetized piece of iron or any other magnetic material made artificially. Okay, so artificial magnets, how they are formed? They are formed by wrapping an electric current carrying conductor around a soft iron core. So in the picture beside, you can see here, whenever the current is flowing from the battery, the light gets on, and yes, it's so much interesting that the clip pins are getting attached to the iron bar. How is it possible? It is possible because whenever current is flowing through the wire wrapped around that iron core is becoming itself a magnet. So this is the magnetization. Let's move to the next slide. Now comes the types of magnets. Basically, there are three types of magnets: permanent magnets, temporary magnets, and electromagnets. We have to learn also the types of magnets based on shapes. There is horseshoe magnet, U-shaped magnet, burr magnet, cylindrical magnet, needle magnet, and many others. For example, circular, ring, rod, and oval shaped magnet as well are there. Now comes the laws of magnetism. The law of magnetism states that the like poles will repel each other and the unlike poles will attract each other. What are the like poles? It's very easy. The north and north, or the south and south. The force of magnetic field flows from the north pole to the south pole. If you hold two magnets close to each other, you will find that if you try to push the two north poles or the two south poles together, they will repel each other. But if you put the north pole near the south pole, they will attract each other and will get attached to one another. Now comes the properties of magnets. Again, the like poles of the magnet repel each other and the unlike poles of a magnet attract each other. A suspended magnet always comes to rest in the north-south direction. We know it very well. The poles of the magnet always occur in pairs. What is the directional property of a magnet? The directional property of magnet states that a freely suspended magnet always points towards the geographical north-south direction. Every magnet, irrespective of its shape, has a north pole and a south pole. Now comes our next topic, that is magnetic field and magnetic field lines. What is magnetic field? Magnetic field is the region or the space around a magnetic material or a moving electric charge. Why moving electric charge has also been stated here? Because we know that a moving electric charge is the carrier of electricity, right? So a moving electric charge also creates magnetic field around it. So within which the force of magnetism acts. So magnetic field is the region or space around a magnet within which its influence acts. That is, within which its force of magnetism acts properly. What are the magnetic field lines? Magnetic field lines are imaginary lines drawn around the magnet. The magnitude of a field is indicated by its line density. Near the south and north pole of a magnet, the magnetic field is stronger and will get weaker when it moves away from the poles. Here in the figure below, we can find the magnetic lines of force of a horseshoe magnet. See, isn't it interesting? These are the iron filings. So it's moving out of the north pole and it's going to the south pole. So it's a closed loop. See here? It's originating from the north pole and terminating in the south pole. So if you look at a burr magnet very closely, you will find that the poles actually lie slightly inside the magnet. That is, the geometrical length is the full length of the magnet, but the magnetic length is the distance or length between the south pole and north pole. So as the south pole and north pole are slightly inserted from the ends of the magnet, so the magnetic length is smaller than the geometrical length of a magnet. And you can see it that near the poles the field lines are more. Here the field lines are more. So here near the poles the magnetic field lines are more. That is, the density of magnetic field lines are more, line density. So the magnetic field strength is also more near the poles, but weaker to other spaces. Okay. So this is the Earth's magnetic field. So it is very often said that Earth is a gigantic big magnet. Okay. So core of the Earth can be considered as a bar magnet. This is the south pole, this is the north pole, right? And the magnetic field lines, they can be drawn like this. Not in a two-dimensional figure, but this is actually a three-dimensional orientation or arrangement. So now comes the most important topic of this chapter and also the most fascinating one, that is the magnetic effect of electric current. When an electric current is passed through a coil, it says that it produces a magnetic field around itself. How can the electricity can produce the magnetic field? Yes, it's saying that whenever electric current is flowing through a coil, it is producing a magnetic field inside. Okay, so if an iron rod is inserted inside this coil, the rod begins to behave like a magnet. Often we use the iron net as the soft iron core. This magnet is called electromagnet. Now you understand what is an electromagnet? An electromagnet is used in electric doorbells, in electric motors and in electric cranes as well. You can see a very interesting diagram has been given here. What is happening? Whenever the current is flowing through this conductor, this iron rod is becoming magnetized. So it is being attracted by this horseshoe magnet. Okay. So very interesting thing is this topic of electromagnetism. What is electromagnetism? Let's learn. Okay. An electric current flowing through the wire produces magnetic field. Okay. This has been understood already. The direction of magnetic field depends on the direction of the electric current. So the direction of the electric current, see here, what is happening? We are changing the direction of the electric current by changing the orientation of the battery. So whenever we are changing the orientation of the battery, the direction of the current is changing and the direction of the magnetic field is changing as well. Simultaneously it's happening. A changing magnetic field can also produce an electric current in an wire, but this is not in your syllabus now. You will learn about this later in your higher classes. So this relationship between the electricity and the magnetism is called electromagnet. So by this compass we are finding the direction of the magnetic field. So it is an application of the electromagnet. An example has been given here of electric bell. So this is a gong, and whenever the electric current is flowing through this coil, it is becoming magnetized, this material, and it's hitting the gong. Okay, and the circuit gets momentarily detached. Again it comes back to its original position. Again the current flows. Again it gets attracted towards the gong because it gets magnetized again. So this is a very interesting thing. So I think all of you have enjoyed while learning this new chapter, right? Okay. So thank you all for watching the video. Please do like, share and subscribe our channel, and don't forget to leave your valuable comments. So I hope all of you have enjoyed while learning the topics of this video. So that's all for today. Thank you for watching the video. See you in the next video. Okay. Bye bye.